Hi, you've probably already watched my first video on how to complete and set up your order of operations informational foldable. While we were setting up, we split this page of paper into two parts. We used the top part to explain some information on how to simplify an expression using an order of operations. The bottom part of this paper we're going to use to explain the distributive property. So we're going to turn our paper again and we're going to write here the distributive property. I'm going to put parentheses around it because it involves parentheses, and it's a good thing to associate parentheses with an expression with this property. So all of this information is going to go on this page, and we're going to talk about it. What the rule for the distributive property is, we're going to write the math rule first. What the rule for this property is that if we have an expression a parentheses b plus c, this coefficient outside of the parentheses means to multiply. Okay, so this means multiply a by what is in the parentheses. Okay, the rule for distributing says when we see this, we can rewrite this. This expression is equivalent to a times b plus a times c. So what this rule says, what distribute means, is distribute means to multiply both terms, which basically is both values, in parentheses by the value outside. So keep going to write parentheses with an I, but it's definitely with an E. So distribute means to multiply both terms in parentheses by the value outside. So when we see A, we say on the quantity of B plus C, we can rewrite that as A times B plus A times C. Okay? So when we start thinking distribute, we need to start thinking of multiply. So let's look at some examples. The reason we use this property is because we don't always have simple expressions, okay? So this is our rule where we use all letters to explain the rule. I'm going to show you a numerical example. So what does a numerical example of this mean? This means if I had, say, 7 times 2 plus 3. What I can do with this is I can say 7 times the first term, so 7 times 2, plus 7 times the second term, which is 7 times 3, will become 7 times 2 is 14, plus 7 times 3 is 21, and we can add those together to get 35. That's the numerical example. Now, we don't always use this property when we're just looking at numerical expressions because we know PEMDAS. So earlier we talked about PEMDAS, and what we could say is, hey, this is an expression, 2 plus 3 is inside parentheses. We're going to do that first, okay? So we could say 7 times 5 because we did what was in parentheses first. Okay, we got 7 times 5. And then we could say, okay, 7 times 5 becomes 35. Either way, we get the same answer. So this is a numerical example of the distributive property. But if we have a numerical example, usually, probably always, they're going to be following order of operation. So why do we have this new property then? Well, sometimes we don't always have a numerical example. Sometimes we have an algebraic example. So an algebraic example means we're going to include a variable, all right? So for example, say that I gave you 5 times x plus 1. The problem with this example is even though there's parentheses and order of operations says to work inside the parentheses first, when I come here to do the addition, I cannot add x plus 1 because these are not like terms. So this cannot be simplified, whereas this one could be, and then we multiplied. So how do I multiply this expression? Well, that's where the distributive property comes in. What we're going to do is we are going to multiply each term by the value 5 outside. I am a big proponent for drawing your arrows. It is important to show that you are multiplying both terms. So when I do this, I get 5 times x is 5x, and then I get 5 times 1 is 5. What I notice here is that these are still not like terms. I cannot combine 5x and 5, even though they both have 5s. This one has an x and this one does not. So I am finished. So that is the difference in distributing numerically versus algebraically. Numerically, we're still going to get that same final constant answer of just the number. Algebraically, we're going to be left with an algebraic expression, and that's an expression that includes variables, coefficients, and constants. Okay? So let's try a few more examples. Let's make up one. Let's do 4 times 3x minus 2. So in this example, again, it's an algebraic example with variables, so we cannot add or subtract in the center of the parentheses, so we're going to distribute. I'm going to multiply each term by 4. Now in this first example, I multiplied 5 times x, and it was understood that this was a 1x. That's why I got 5 times 1 is 5. In the second example, I have 4 times 3x. So what I'm going to do is I'm going to do 4 times the coefficient 3. So 4 times 3x would become 12x. Now this is where it's a little tricky. This isn't just 4 times 2. We're going to consider this a negative 2 because there's a subtraction sign in front of it. That subtraction sign and negative sign are going to be interchangeable here. So we have 4 times negative 2, which is going to give me negative 8. So as you see here, again, this is an algebraic expression. These are not like terms. I cannot combine these. All right, for our next example, what if I give you negative 8 times 3y plus 5z in the parentheses, and then I add it in here in an additional plus 1z on the end? How would I do this one? Well, what I'm going to do is I'm only going to distribute to what is inside the parentheses. Again, I'm looking inside the parentheses first per order of operations. These cannot be combined, so per order of operations, I would do multiplication next. This means to multiply, so I'm going to multiply before I add. So I'm going to distribute to each term. I will get negative 8 times 3y is negative 24y. Negative 8 times 5z, a negative and a positive is going to be a negative 40z. And then I'm not going to distribute to 1z because 1z is not in parentheses, so I'm just going to say plus 1z. Now, this one's a little bit different because when I go through that process, I've undone multiplication per order of operations. Is there any addition or subtraction I can undo or I can do here? Yes, I can do that. I can say, hey, negative 40z and a 1z. So I have 40 negatives and 1 positive. So that 1 positive is going to cancel out one of my negatives. And I'm going to end up with negative 24y because nothing was like it, and a negative 39z. That would be my solution. And that's all I can do because, again, these are not like terms. We're going to do one final example here just to make sure everyone understands this. What if I gave you a negative times 9a minus 2? How would I do this problem? What you have to understand is that this still means to distribute. This still means to multiply. Just what am I multiplying? Well, I'm going to be multiplying a negative 1. It's understood that there's a negative 1 right there. So I'm not just multiplying by anything, I'm multiplying by negative 1. So negative 1 times 9a and negative 1 times negative 2. This will simplify to negative 9a because negative 1 times 9a is negative 9a, and negative 1 times negative 2 is positive 2. Again, this is an algebraic expression. It cannot be simplified further than this because these are not like terms. And this is our example of the distributive property. We should always think multiply when we think distributive property. So whenever we see something, a term, a constant, or a variable or a constant outside of parentheses, we need to assume that means to multiply and see where that falls in the list of order of operations. If we can simplify what's in parentheses first, we're going to do that. But since we're in an algebra and pre-algebra level, we're not going to see that as much. It's going to be more these algebraic expressions. I hope this video helped and that you now feel confident in using order of operations and the distributive property in simplifying algebraic expressions.